On this last portion of the review, we're going to do some review of regular polygons and interior angle sum and exterior angle sum of polygons. So the big key to remember in this lesson is that the interior angle sum has the formula n minus 2 times 180 degrees. Okay, this will always give you the interior angle sum. Now, the other key to remember is that the exterior angle sum is always 360 degrees. It never changes. No matter what shape it is, it's 360 degrees. So what that means is, for the exterior angles, if I added 80, 110, whatever this angle down here is, and whatever this angle here is, that would always add up to 360 degrees. Okay, so with that said, we need to find out what all these angle measures are. So let's first start by using linear pairs. 80 and x, 80 plus x has to equal 180 degrees because it's a linear pair. So x is equal to 100 degrees. So this is 100. We can do a linear pair here for y. 110 plus y has to equal 180 degrees. So if we subtract 110 from 80, we get 70. So y is 70 degrees. And finally, to get z, you need to use the interior angle sum theorem, which is n minus 2 times 180, to find out what all four of these angles add up to. Or you could just memorize that it's a quadrilateral and the interior angle sum of a quadrilateral is 360. But let's do it just in case you didn't know. So since n is the number of sides, we have 4 sides in this quadrilateral. So we're going to do 4 minus 2 times 180. So this is 2 times 180, which gives us 360 degrees. So the interior angle sum of this polygon is 360 degrees. So to get z, we need to set up the equation 100 plus 105 plus 70 plus z equals 360 degrees. So we can do some math and add those together. 100 plus 105 plus 70 is 275. So 275 plus z is equal to 360. And you can subtract from 360 the 275, and we get 85. So z is 85 degrees. So here's our answer for x, y, and z. Okay, moving on. Complete each statement with sometimes, always, or never. Now for this, you need to have memorized your parallelogram chart. Remember the hierarchy. We have a parallelogram at the top. Underneath the parallelogram, we have two types of parallelograms. We have a rectangle and a rhombus. And then both a rectangle and a rhombus turn into a square if it gets specific enough. So we read this by saying a square is always a rhombus, a square is always a rectangle, a square is always a parallelogram. A rectangle is always a parallelogram, a rhombus is always a parallelogram, but a parallel is sometimes a rectangle, sometimes a rhombus, and sometimes a square. Anything below, it's sometimes. Everything above the shape is always that shape. So, a parallelogram is blank a trapezoid. Is there any trapezoid underneath this parallelogram diagram? No, so we will put never in this figure. A square is blank a rhombus. A square is underneath a rhombus, so it's always a rhombus. Okay, a rectangle is blank a square. Well, it could be a square, but it doesn't have to be, so we're going to say sometimes a square. Okay. And number 3, find the sum of the interior angles of a 15-gon. So we want interior angles, so we're going to use the interior angle sum of n minus 2 times 180. N is the number of sides. Since we have a 15-gon, we have 15 sides. So we will substitute in 15 for n minus 2. So 15 minus 2 times 180 will give us the sum of all the angles. So whatever 13 times 180 is going to be the sum of the interior angles. So we'll do 13 times 180, and that gives us 2,340. So this answer is 2,340 degrees. Okay, so we wanted the sum, so we got the sum. All right, now find the measure of an exterior angle of a regular heptagon. Well, a regular heptagon, hept means 7, so this is a 7-sided figure. So if we want only one exterior angle, n means 1, so we only want one angle. So you have to take the sum of all the exterior angles and divide it by 7. Since we're dealing with exterior angles, we said at the top of our page that the sum of the exterior angles is always 360 degrees. So we'll substitute 360 for the exterior sum, divide it by 7 to get one angle. So 360 divided by 7 is 51.4 degrees. Okay. And going on to letter B, what is the measure of each interior angle of the same regular heptagon? Well, we can do this a couple ways. We know that the interior angle is a linear pair from this diagram. All the exteriors and interiors will form a linear pair. So we could just do 180 minus 51.4 degrees to get the interior angle. So that's 180 minus 51.4, which will give us 128.6 degrees. Or we can do this using the interior angle sum theorem, which is n minus 2 times 180, and then divide by the number of sides, which is n. So in this case, we're going to do 7 minus 2 times 180, and then divide by 7, since there are 7 sides. So 5 times 180 is 900, and then 900 divided by 7 is 128.6, which is what we got over here. So either method works. I just wanted to show both of them. So 128 degrees is the answer there. Okay, and number 5, we need to write an equation and solve for the variables. So we know that this is a quadrilateral because there's 4 sides. So the sum of all those angles is going to be 360 degrees. Again, if you didn't know that, use your theorem, n minus 2 times 180 degrees. So we'll set up the equation 7x plus 3x plus x plus 76 plus 3x plus 4 is equal to 360 degrees. So let's add up our x's. 7 plus 3 is 10, 11, 12, 13, 14. So we have 14x. And we'll add, that's at 80 equals 360. So we'll do 360 minus 80, which is 280. So 14x is equal to 280. Divide by 14, and x is going to be 20. So the answer for x is 20, but we are not finished. We need to find all the angles. So angle P is 3 times 20 plus 4, so that's 60 plus 4, so that's 64 degrees. And Q is 7 times 20. 7 times 2 is 14, so this will be 140. So that's 140 degrees. Angle R is 3 times 20, which is 60. So angle R is 60 degrees. And angle S is 20 plus 76, which is 96. So this is 96 degrees. Now, we always want to do a double check, so we'll add up these 4 angles to make sure they add up to 360. So 64 plus 140 plus 60 plus 96 is 360 when you add them up. So we got that correct, most likely.